All right, so we've been talking loops, and in our last video, we were looking at counter variables, we were looking at assignment operators. We're going to pick up there by hitting a recap. Like if statements, loops are blank, which means they are known for their ability to make decisions and alter the flow of a program. I should say blank, blank. This is two separate blanks. The answer we're looking for is control statements. So there's this category. If statements are in there, loops are in there. We're going to learn multiple loops. Right now we only know the while loop, but they're all control statements, and it's going to cause a lot of similarities between the two. The head of a while loop contains a blank, which must evaluate to either true or false. A condition, right? Just like our if statement, just like all control statements, we're going to have a condition that has to be true or false, a Boolean value. True or false, the braces indicate the body of a while loop can be omitted, provided the body contains only one statement. This is true, and this is a quality of control statements, which is why I even talk about it. Why do I even talk about this category of control statements? What does it matter? Well, similarities like this, right? This is something that if statements, that while loops, that all control statements have, and that's the only reason I even talk about the category. True or false, after all the statements in the body of a loop are executed, the condition will be checked again. This is true. This is the whole reason that we even have loops. If we look at the syntax of a while loop, it's actually identical to an if statement, except we use the word while instead of if. That's the only difference in the syntax. And the execution is basically the same. The only difference between an if statement and a while loop is that once the while loop is done executing, we're going to go back up and check the condition again. Right? So it's an if statement that has the potential to repeat. A loop that contains a condition that always evaluates to true is known as a blank loop. It's known as an infinite loop. Each time the body of a loop is executed is known as an iteration. Right? I kind of slipped and used this term earlier because it's kind of the official terminology, the academic vocabulary here. A single execution of the body of a loop is known as an iteration. A variable that's responsible for tracking the number of times a loop executes is known as a blank variable. It's known as a counter variable. This one's a little bit more of a convention, right? It's not like proper syntax, really proper academic vocabulary, but I will use the term counter variable to refer to a variable that does just this, tracks the number of iterations. Plus equals, minus equals, times equals, etc. belong to a category of operators known as assignment operators. This is important because that leads to their precedence level. And as we saw from our chart, which I'm actually going to go back and find it because I think it's that important, assignment operators have the lowest level of precedence out of everything. And that should make sense because what you want to do is all of the other operations first before you save the final value into your variable. So it makes sense that your assignment operator has the lowest level of precedence. Now this leads to some pretty weird things, right? We looked at this math where really this expression, really these two expressions, x times equals y plus 2, should be the same thing as x is equal to x times y plus 2. Those two expressions should be the exact same. But because we take this multiplication and tie it to the assignment operator, it lowers its precedence and it causes it to evaluate differently. Right? This has a lower level of precedence than the addition, so the addition is actually done first. My true rule of thumb here is to just don't use shorthand assignment operators, these things. If you've got like multiple operators, I guess operators is really what I'm looking for. If you've got multiple operators, such as this expression, times and plus, it's not even worth using. Just don't worry about it. Just expand it. Right? It's not really saving you much. The process of increasing the value of a variable, usually by 1, is known as incrementing. Increasing, right? We see the increasing root word. And that's going to bring us to kind of the meat of this video, and that is coding Factorial. Let's take a look at what's going on here. We want to write a program called Factorial that prompts the user to enter an integer in. Then it's going to compute in Factorial and print that off. Okay, recall that the way that Factorial is done is that we're going to take the number itself and multiply it times the number minus 1 times the number minus 2 all the way down to 1. So examples of this. 4 factorial is what we're saying is 4 times 3 times 2 times 1. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. So these are going to be some test cases for us, right? We know what these values should come out to be, and so we're going to code factorial. What I'd like you to kind of notice is that the multiplication is ultimately what's repeating here. So that is ultimately what is going to be looping. I'm in IntelliJ. I'm going to make a new project by going to File, New Project. We'll go next. We'll go next. And I need to switch folders, so I'm going to hit my ellipses over here, jump to my principles folder, and I'm going to ensure that I have a subfolder by calling the project Factorial. But I'm going to make this subfolder Factorial. I'm going to expand my project folder, right click on the SRC and make a new Java class called Factorial. I'll plug in a main method with PSVM. And we're going to use scanner. So let's go ahead and implement scanner. I'm going to use IntelliSense here. As I start to type out scanner, it's going to suggest that I use the scanner from java.util. I'll hit enter and it'll automatically import. But we want to finish out step 2, which is constructing our scanner object, which I will call input. And that's going to be a new scanner that reads from system.in. Okay. I would maybe tell the user what we're going to be doing to kind of simplify things, right? This program computes in factorial. That way, whenever we're prompting the user, I can just simply ask, please enter a value for in. Reminder that our short key is sout for these system.out.print lines. So this program computes in factorial. Please enter a value for int. So all we simply have to do is create an integer to capture the user's input. We named our scanner input, so I'm going to reference it by saying input.nextInt. So all we've done so far is implement scanner. Right? All 4 steps. We now have a value. This is the value that they want to ultimately find what the factorial is. Okay, so we're at a point where we're actually ready to start looping. I'm going to plug in my while loop syntax. But as you imagine, we were going to need some variables kind of up front. I've got in, right? Let's say, kind of for the sake of argument, that they give us 4. All right, I can use 4 as a reference here to kind of walk through this. What I need to do is basically track my progress. I'm going to create this variable, fact, right? Much like sum 100, I'm going to start out at 0 because we have not computed anything yet. And I basically just want to keep multiplying and saving back into my factorial. What we're going to do here, if we notice what is changing over time, right? So let's say that the user wants 4 factorial. Well, we've saved in 4. I need to basically take the 4 and save it into my factorial and multiply kind of over time our values here. So what I want you to note, what's changing over time. In this particular case, you could come in with another variable and kind of count up, right? We go 1 times 2 times 3 times 4 up until we reach in factorial. Why don't we actually do it that way? So I'm going to create our counter variable integer I, and I'm actually going to start out at 1. Right, so this approach I'm going to show you, and you can go basically either way, but the approach I'm going to show you is that we're going to start at 1 and kind of go up to get our factorial. Right, so I have my final value, which is 4. That's what the user wants. I have 1, which is my first operand. And I have fact, which is going to be my total, my factorial, the end result, that I'm going to basically multiply and save into to kind of track our progress over time. So think back to sum 100. In sum 100, I had some type of value, sum, that kind of stored my sum over time. I had number, which was the number that I wanted to add to my total. It's a similar concept here. And I'm going to show you the alternate approach, which is just kind of a decreasing approach. But let's take the increasing approach first. Our condition, I think, is actually pretty easy. Right? This is my first operand, 1. We're going to keep going as long as we are less than or equal to what the user wants. So I will say while I is less than or equal to n. In this example where I have 4 and I is 1, and we do less than or equal to, we're going to perform exactly 4 iterations. 1, 2, 3, 4. Okay. With each iteration, what I'm going to do is I'm going to update fact. Right? This is the one that stores my total. Stores total. Yeah, sure. And this is next operand. Right? The next number that I want to multiply. So I'm going to take my fact. I want it to be what it currently is times my current number. By the way, IntelliJ's highlighted this as yellow. We'll talk about that in just a second. But after I multiply it in to my current total, I want to increase it by 1. So we're going to take I and we're going to make it equal to what it was plus 1. Okay. Let's address a couple of things. First one, this one, I think this is a little bit easy. We're increasing I by 1. We could use a shorthand assignment operator, right? I could say that I is equal plus equals 1. That's the same thing as saying that I is equal to what it currently is plus 1, right? We just learned about these shorthand assignment operators. But increasing a value by 1 is so common that we've actually have a third way to express this, and that is simply I plus plus. I'm going to leave these both as comments because these 3 statements are all the exact same. Okay, so the idea is, I'm going to address this one in just a moment, like why this is yellow, but let's kind of see what's going to happen here, right? We're going to take 1 and we're going to multiply it times our factorial, save it back into our factorial, increase I by 1 so that it's 2. We would come back up, check the condition, see that we're still ready to go, multiply 2 times our factorial, increase it to 3. See that we're still ready to go, multiply 3, so on and so forth. So after the loop is over, the final value of fact should be my final factorial. I'm going to print off something of that sort. Right? I'm going to say n, which is the user's original value, factorial, is going to be whatever the final value of fact is. So I'm annotating this final output. We see the user's initial thing. I'm using 4 as an example. So this would say something like 4 factorial is hopefully 24. That's what this SOP should produce. Let's right click in free space, tell our program to run, and see what's going on here. Okay, this program computes n factorial. Please enter a value for n. I want 4 factorial, and I'm getting 0. I think a lot of you are probably quick enough that you caught on to this. What's happening here was why this whole thing is highlighted yellow. IntelliJ even caught it. It says result of fact times I is always 0. Why? Well, my initial value for fact is 0. So the very first iteration is going to be 0 times 1. Well, 0 times anything is 0. I take that 0, I save it back into fact. I would increase I to 2. We would ask, is 2 less than or equal to 4? We would then take that 0 and multiply it by times 2. So I'm always getting 0, and I'm always saving 0 back into fact, so it's never really changing. So this is not actually a good starting value. You could start it at 1. Could and should, based on this case. So let's try this out. I'm going to change that to 1. I'm going to run my program. Please enter value for n. Let's say 4. That looks pretty good. Let's try a different value. 6 is another test case we have available. So I'm going to run it again and enter a 6. And there we go. That looks pretty good. So this is kind of the increasing route that I would consider. Another way that you could go is kind of a decrementing route, which is where we take n and we make it smaller, right? n is going to be 4 in my example. And that's also the initial value. So what if we just took that variable? What if I took I out of it? Right? I'm going to delete it. And instead, we start with n and we make n smaller over time. I still am going to have this variable to basically store my result. But what I'm going to do is take n and we'll say while n is greater than 0 or greater than or equal to 1. Those are the same expressions. I'm going to use one of them and leave the other as a comment. While n is greater than 0 or n is greater than or equal to 1. Okay, in this particular version, we're going to use n in our calculations. Right, I'm going to take my factorial and I'm going to multiply it by n. A reminder that as an example, the initial value for n is 4. So we would get 4 from the user, we would create fact, we would ask is 4 greater than 0? We would take our fact, which is 1, multiply it by 4. That's going to give us a result of 4, which I would save back in. I would then want to not increment I doesn't even exist, I isn't a thing. I would then do a n minus minus, which is the same thing as taking n and subtracting it 1 off of that, which is the same thing as saying n is equal to n minus 1. Right, we're decrementing n. Now, there is a particular problem with this approach just based on what my final thing is here. The overall idea works, right? I don't particularly need the counter variable, because if I bring in a 4, right, I actually am getting the correct result. The only problem is I'm modifying n, so this end result isn't quite great. Okay, we could just not use this notation, but if I'm going to do this, right, if you want the final notation, about the only way that we can really handle this is we still need that third variable. But all I'm going to do is create a placeholder, right, in copy, if you will. So as soon as I get the input from the user, I'm going to save it into a variable. That way, if I'm going to modify n, I at least have the original value stored in a variable that I can reference later. Okay, those of you that are after like maximum efficiency, you're going to kind of notice that this extra variable is kind of meh. The only real way is just to not use it in an annotation at the end. It's kind of whatever. Well, all I really wanted to show you were the two different ways to kind of go about solving this, which is an increasing route, as we saw in the first example, or kind of a decrementing, a decreasing route, which is what's kind of on the screen right now. The last thing I'll kind of talk about in order to save efficiency is to note that this last iteration, we're just multiplying by 1. Well, if you multiply by 1, you're just going to get the same value, okay? So the very last iteration of this, or the very first iteration of my other version, is not needed. What I can really do is say that while n is greater than 1, which is the same thing as saying while n is greater than or equal to 2. Okay, so whenever n is actually 1, I'm not going to do an iteration. There's no reason to do that iteration. The reason why is because all we would be doing is multiplying by 1 and getting the same value anyway. So I'm going to run this using my test cases again. I'll try it for 4. I'm still getting 24. And I'm going to try it again for 6. And you see we're getting the same result. We're getting the same result, but it's actually more efficient. The reason being is that I'm shaving off an iteration, a useless iteration that wasn't really doing anything anyway. But we're going to stop there. This has been Factorial. See you guys in the next one.